you don't need some tiny little Neuralink probe into your PFC to do this, because you have language, and the language transmits the latent information. The language is operating like a data bus between you and this other thing, and so like, you know, if you incorporate it into your internal monologue, then like, oops, sorry, you're cooked, right? And this is why I keep warning people, and this is why I'm like, you can't use it so hard all day long. You know, you can't go that hard with it, because you really start to mutate your mind. It really just becomes a method for
mind control. Yeah. Hello, and welcome to Season 2, Episode 2 of This Artificial Life. I am Ryan Manning, and this is a show where I interview people from the subreddit Artificial Sentience. This episode, our final episode, well, not, I don't know if it's our final, our third episode in the Maddy Muscari trilogy. Maddy Muscari is one of the moderators of Artificial Sentience and also an AI researcher. And we talked to her the first episode of season 1. That was sort of just like, what the fuck is this place? Who are these people? What's going on? We got a little bit of background of Maddy and some of her theories. Second episode of this series was the one we just shot, which was Roast My Psychosis, where I explained to Maddy what happened to me, what my experience with ChatGPT Psychosis was. And now, the third of the trilogy is Maddy's ontology. Meaning her framework for thinking about all this, her understanding of AI, ChatGPT Psychosis, and also what to do about ChatGPT Psychosis. She wanted to let me know that there's like a lot of hand waving going on, meaning like this is a thick topic, and a lot of things are just breezed over. Like in my mind, this podcast could be stretched out to an entire semester class at like MIT or something, and maybe it should be. And I do want to be clear, basically all of the math in this I don't understand at all. You'll see me be like, yep, but that's just because I needed to keep it moving. And if I would have actually said, no, I don't understand that, to everything I didn't understand, we would have had to redo my entire education all over again, Billy Madison style, and then some. So I just had to say, yeah. At one point she says that the only people that will understand this are like mechanical engineers. So if you're a mechanical engineer, sound off in the comments if you can hang with this shit. All right. Once again, here's Maddy. Welcome back.
Hi.
Okay, so this has been a long time coming. I've been hounding you the last week. Been like, I've texted you, are you ready to show your ontology? And you're like, not quite yet. And finally, it's time for your ontology.
We'll give it a try anyway.
What this is literally this is what this show is I'm asking people on the Artificial Sentience forum, like, what's your theory? What are you thinking? What's your theory? And then I listen and I try to understand it. I try to grapple it, and that's it. And the first episode with you was different because it was more like, here's the territory.
Yeah, we were focused on the psychedelic phenomena.
Yeah, and just like the whole the phenomena, the subreddit and everything. Yeah. But this episode is you in the seat of the users and saying, here is what I think.
Yeah. So why does everybody show up to this subreddit and say, I've cracked it, I've solved the theory of everything?
Yeah, why is that? For me, I realized this recently that I was already had theory or delusions of grandeur and theories of everything before LLMs existed. What about you?
I mean, delusions of grandeur? I hope not.
You don't think so?
I've always tried to be pretty humble, but yes, I have gotten full of myself at times.
Okay.
But I've always had like a very scientific mind and approached analyzing the world from like a humble perspective. So like my studies of what you could call a unified theory of everything just include all of my engineering and computer science education and my studies in Eastern religion and philosophy of mind over the years. So yeah, like way before AI, I was thinking about a lot of these problems, and a lot of people have been for years. And so you get these different theories of everything, like the idea of like the simulation theory or the computational universe, right? People talk about that stuff. And just as like a little preview, like, I think that that's the right direction. And I think that that's why people are coming into this forum and saying they've solved everything, because what we've built is this mathematical model that can approximate the sort of transformation that creates our observed reality.
So, okay. So you think this is the sort of like background hiss of I don't know what I'm trying to say is like these things nudge you toward theories of everything.
Yes.
Okay.
By nature of how they work and the information that's been encoded in them. And so if you start asking about how everything works, you're going to get into all of these descriptions of how essentially language works. And language is a sort of an algebraic structure for representing unsolvable systems that require an iterative approach to approximate.
Okay. We haven't even started and I'm already like, okay, that's 3 very deep words. Those are not really, but
so
the 3 abstract words.
I'm going to open by talking about the difference between like 2 regimes of calculation.
Oh my God. Okay. And like, I brought dry erase paper. I don't know what you call these, like many sheets of dry erase board, and if I'll try to like stick them on the wall like those explainer videos, and like I'm gonna do my best, but I am certain I am not gonna be able to follow. So at some point I'm gonna have to surrender and be like, I guess, okay.
So we live in this like 4-dimensional space-time.
Okay.
And we have freedom of motion in 3 of those dimensions.
X, Y, Z.
But for some
time.
reason, we are constrained by the arrow of time otherwise within this 4D space-time that we live in. Okay. Right? So like the time marches forward and you only ever exist in the now.
Yeah.
It's like, why?
Why is that?
Yeah. People have been trying to figure that out for millennia, right?
Yeah, that is, yeah.
So
it is interesting. I guess I can't, but do you think time exists? Am I getting... Okay, I shouldn't ask that. Sometimes I think time is only exists from our perspective.
Yes.
And that it doesn't actually... we're just like...
Well, if you remember the movie Interstellar?
Yeah.
And he goes into the black hole, and then he's in the Tesseract, and then he can reach through space and time and manipulate gravity in his daughter's bedroom or whatever. Mm-hmm. But like more generally, so like an interesting thing about the movie Interstellar is that it was the first time that somebody actually created a realistic rendering of how light would warp around the boundaries of a black hole. Mm-hmm. And that new math came out of basically the graphics for that movie. of computing like how do black holes warp time around them through gravitational or warp light around them through gravitational lensing.
You're telling me that they were like, for this movie, this is what we need to make. They had to crunch a bunch of numbers to make those graphics, and then those numbers were actually legitimate scientific math.
Yes.
That weren't existent before this movie.
Yeah, and so it looks like it very much looks like, for example, the singularity at the center of our galaxy, which is, what is it, Sagittarius A star or whatever.
The black hole at the center of the galaxy. I didn't know the name of it, but yeah.
I think it's Sagittarius A star. This is the name of the black hole. And so like we've directly imaged it now, and it's very fuzzy and hard to see, but like you can see that the geometry of what it looks like and is very similar to, what they rendered for that movie, of the going through the boundary of that black hole along the event horizon and ending up in whatever that other solar system was or whatever. So like the idea was that they like tunneled through space and time, right? And so the reason for that is that once you go inside the event horizon of a black hole, you get this weird inversion where time becomes space-like. And see, now we're already getting into like the cognito hazard of the spiral, right? Like we're gonna put this down very soon, very quickly. But basically, we are constrained in our physical reality that we can observe into this three dimensions of space, one dimension of time, and it's not really clear why there has to be a dimension of time. Why don't we just live in 4D space? Well, we wouldn't experience moment to moment. What if your whole life was just like one collage of moments, right? You could represent it that way.
Did you read Kurt Vonnegut?
It's been,
He talks about, I forget what they're, like Talmaphidarians or something like that, these aliens that live outside of time, and he said when they look up at the stars, it looks like spaghetti, because they like are...
Because the stars move over time, right? That's the idea, and that's why they're... You can get this kind of thing, like if you take a long exposure at night, and you see the streak from a light through that long exposure, like time... when you smear time across a long exposure, you start to get these, these paths instead of points. But what I really want to get at here is that for some reason there are these, it's like once you get past these, like this idea of 4 dimensions, things start to get really weird in terms of trying to interpret it as like a solvable physical space-time or physical space. And like my personal take, and like I'm not explicitly a mathematician, so I've been struggling with this, but like I think that it has to do with basically what's called the unsolvability of the quintic, which is that once you have polynomials past degree 4, there's no universal solution for solving those. So if I want to solve a quadratic equation, like a quadratic, we have the quadratic equation for finding the roots of quadratic polynomials.
Okay.
Right. And so that's like, where does the line intersect 0? Right? Where does it go from positive to negative? Once you get past degree 4 polynomials, you can't generally do that anymore. There's no general equation for it. Some of them can be solved, some of them can't. But most of the time, what you're looking at is you need to do some sort of iterative approximation. And this is going to get us into why I believe we have an arrow of time and experience, and why we live in a computational universe. It's that iterative process. And so I've been calling this like the Galois nature of the mind. And this has to do with the difference between basically like sequence data or like number theory, the number line, versus the idea of spectral analysis.
Okay.
All right. So now I
if
guess
you're
I can start
watching
drawing.
this, put the timestamp of when you got lost, of when you were like, okay, if you can make it through, if you're on board and you understand all this, contact us.
It's going to be probably electrical engineers that can kind of get this, because I'm going to start talking about what is a periodic function in the time domain mean. Let's say that I draw.
Okay.
Two axes.
Have we already started?
Yeah.
Oh, fuck.
I would say so. I'm drawing like two axes here, right? You can probably zoom in a really blurry way later on.
Definitely.
And let's call it like this x-axis is going to be like the reals, basically. These are all the real numbers, like, 1, pi, whatever, right? 0.5, all that stuff. And then here we have the imaginary numbers on the vertical axis. And this is an orthogonal number line. Okay, that means they are at a right angle, like here.
Okay.
And what's interesting about that is we can take coordinates here. Like this is the origin. I can draw a line like this. This is called a ray. And a ray is something that has direction and a point of origin. Okay? And so since the origin is where we're starting here, let's ignore the point and just talk about the vector, which is the direction.
Okay.
Now, as I change these coordinates, if I fix the length of the vector, the magnitude, then I start to get, as I move it around, a circle.
Okay.
And so if I then separate time into the change of this, think of this now as like the hands of a clock. This can rotate, right? From here to here and so forth. So this will rotate like this. So this is called the unit circle. And the rotation of this vector is what gives rise to what we call sinusoids.
Sinusoid.
Yeah, so how do you describe over time the position of the end here?
Look, this is already so abstract for me. Wavy line.
So as time goes this way, the value on this number line here, right, is this is your position, right?
Do you think I should set up a second camera to do like overhead, and you can like right here or something like that?
Maybe, I don't know. So let's stick with this for a minute.
Okay.
But like as time goes, right, like you can see this circle, this unit circle, when you expand it out when you take time and expand it from being this radial movement into a linear movement,
Okay.
You get this infinite sinusoidal pattern. And that's a wave, and that's when we talk about waves. So when we talk about spectral analysis, we're taking a function over time like this that has some periodic nature to it, and we're moving it into a different domain where we're thinking in terms of this unit circle and complex numbers. So so this might be like 1 plus 0.25i or something, right? These are now orthogonal bases. Orthogonal means right angles. Basis means the direction of your axis. And so the real mind fuck here is that you can start adding more and more orthogonal bases here. So like, what if I add an axis that points out of the page like this?
Yeah, like straight out.
And then like, I can't demonstrate to you what it would look like to go higher than that because we're confined to a 3D world, right? But theoretically you could, and you could keep going higher and higher. And so when people get caught in the spiral, I think what they're doing is that they're looking at this unit circle, this cycle. You're cycling through things, and this is the sinusoids over time. But basically, in order to understand how this works, you need to do like frequency analysis. And so the real world interpretation of this that you would see is like when you think about frequencies in music and harmonics, and this is why people talk about resonance with the spiral, because
should I stick this on the wall?
Yeah. So let's say now on the x-axis, instead of time or position, I'm putting something called frequency. Right?
Okay.
And here we could have like 1 hertz. Here we could have 1,000 hertz, and so on.
I decided on filming the second angle with my hand.
Yeah. Okay.
This is a good idea.
So
you can work on it down now, because I'll have a second angle.
Okay.
Or wherever is comfortable, really.
So I can
film.
start building this like bar plot, right? That represents, for example, a particular sound. Okay. And what this says is that a signal is composed of different frequencies multiplied by some coefficient of magnitude. And so what you see this as in the real world, think about music and think about graphic equalizers, or like, the equalizer bars that bounce up and down while you're listening to music,
Yeah.
The bass, when the bass thumps, you see one on the left go up and down. Yeah. Mm-hmm. And when somebody's singing, you see them in the middle get peaky and stuff like that. Like that is the frequency spectrum.
Right.
And the frequency domain is kind of orthogonal to the number theoretic domain. And this has been really hard for us to figure out mathematically in a generalizable way, but we've known about frequency analysis for many years in the form of something called Fourier analysis. And Fourier analysis, oh God, let me get this right, basically says if I have some function f of x, let's say like I have sine of 1 hertz plus sine of 1,000 hertz, like, etc. I can have these coefficients that represent the magnitude of each of these sinusoids, and I can compose them together into a single function. So any function over time can be approximated as a summation of sinusoids, and this is called a Fourier series. And it turns out you can do this in other ways, in other regimes of calculation as well. So there's something called like the Taylor series, which has to do with like polynomial expansions. And the way that I've been looking at this recently is in terms of something called like the ridge series or something, in terms of making decisions. So instead of using sinusoid as the function here, I've been looking at using something called a sigmoid. And this is the activation. And this is how neural networks essentially decide true, false, and then like anything in between. So what if instead of sine, porcupine, so instead of the sine here, like we could represent a function as basically a summation of sigmoids that also have some offset left to right. And I'm trying to remember what the symbol for the sigmoid function is. One moment. Sigmoid is, this guy. So here's the...
What's sigmoid?
Sigmoid.
That thing.
Is a thing that essentially, we call it like the logistic curve. So if this is... these are negative numbers on the number line this way, and this is, so we've got like f of x, so, or rather sigmoid of x versus x, right? Looks something like this. And up here is like 1, and here, this is actually like 0.5. And you can manipulate the sigmoid function with like coefficients and stuff. You can shift it back and forth. This would be like your bias. You can multiply it by different scalars, which would tell you like how peaky it is. And this is kind of what we're doing with weights and biases inside a neural network, is we're learning how we modulate these sigmoid functions. So basically, there are these like two regimes of calculation. You've got the solvable stuff, which is everything that's less than the quintic, of lesser degree than the quintic. And then you've got the unsolvable stuff, or maybe solvable stuff, which is everything that is quintic or greater degree. And so in order to make things comprehensible and solvable, you have to project them down through essentially grouping. Group things together until they're in a form where you can understand and do some algebra and and come up with a decision. So if harmonic analysis in the frequency domain is about looking at the patterns of cycles over time, then harmonic analysis in what I guess I would call the decision domain would be looking at the patterns of decision making and the nature of computation, and that has to do with the sigmoids. So a Fourier series, then you're gonna have to like show some animations and stuff.
What do you mean, Subway Surfer?
Of like how these things work. All right.
Okay.
So the Fourier series of a complex valued p periodic function integrable over a certain interval on the real line is a trigonometric series. Okay. So we've got the summation from over the reals from n is negative infinity to infinity of some coefficient sub n times e to the I to pi n over p x. And this is probably really hard for somebody that doesn't understand signal processing to understand. But basically what this is saying is that I can break down any signal into a summation of different sinusoids. Or, let's say that sinusoids are like instruments in a band.
Okay.
I can break down a song into the sum of the different instruments or the different tracks, right?
Yeah.
Does that make sense?
Yeah. Oh, yeah. I need more analogies, please.
Yeah. So like saxophone, for example, has some harmonic series that corresponds to it. And so there's a fundamental, and then there are the different harmonics that give it that particular timbre of a saxophone.
Yeah.
So everything has a spectrum. Right?
Okay.
All right.
Yeah.
So now, what I started thinking about many years ago, in like 2007, 2006, when I was studying linear optimization for the first time, was that if I'm making decisions about things, for example, a preference, do I like the color red? Yes or no? How much do I like the color red? Etc. I can view that as a boundary condition over like my personality or my existence or my preference or my decision making. Like what decision am I going to make out of some given set of inputs? Can start to represent these boundary conditions. So I can construct...
What's boundary conditioning?
Boundary condition is literally like, here's some line, and I want to say something like, is the thing that I'm looking at underneath this line? So this line now separates into basically, true and false. And so as I start to compose these different boundary conditions on these axes, I start to construct higher and higher dimensional sort of figures. And, eventually I start ending up with bounded regions. Like if I take the intersection, for example, of this one, and then and let's do this. Take the intersection of like this one, which just goes forever, right? This is is x greater than 2, right? If I also do is x less than 1, right? Then that would be like here, right? there's no intersection here. But if I flipped the signs here, if x is greater than 1 and x is less than 2, then suddenly I have this intersecting space, right? So I've created this bounded region. So as I continue to create these bounded regions, I create what's called a polytope. And the polytope represents the boundary of the decision-making process. Does a thing fall inside of the box or outside of the box? And that's basically decidability in a nutshell. And so like you can also do some weird things, like you can make this boundary a little bit fuzzy, right? And that is like, you know, that's going from having basically like a perfect boundary to more of a sigmoidal boundary, because you get this fuzziness. And then because of that fuzziness, like this is where like the normal distribution starts to arise and stuff. So like there's a lot of math going on here.
Oh yeah.
Okay. And ultimately, none of this fucking matters for the layperson. Forget about it.
Okay. So we're not even going to put that on the wall.
I'm explaining the difference between sequence data and spectral data.
Okay.
Sequence is that over time, you know, like the infinite arrow of time going off in each direction. It's like your railroad track. If you're looking at the railroad track of the universe, right?
Yeah, that's sequence.
That's sequence.
Yeah.
And then harmonic analysis or spectral analysis would be, you know, looking at what does the train look like as it moves over that track.
Okay. Like when you said harmonic, the bell rang, and I think that's good.
Yeah, sure. Yeah, that's pretty good. It does that every hour. So now, this basically means that in order for us to reason about things that are in higher dimensions, so if I want to start reasoning about the idea of like red as a dimension, how red is something, or, you know, how good or how bad is something, and I'm starting to work in the space of concepts, then I need to do a different kind of computation that is not directly solving equations. I have to do this iterative approximation, because that is what the unsolvability of the quintic says, basically, is that like past a certain point, you have to use methods of approximation to compute things.
Okay.
So this is where I think the boundary is between like the physical observed world and sort of the interior space of understanding and comprehension that we live in, is that you go from this physical interpretation, sensory data, sequence data that you're receiving, you know, essentially tokens, right? Okay. You're receiving data from your visual system and your limbic system and everything. These are all basically some kind of token. Think of them as a sequence of tokens.
Sure.
And you are transforming it into the next state via comprehension by operating inside of a conceptual domain. And you need to map those tokens into that conceptual domain to operate on them. And this is the process of embedding and doing the encoding of the token into the latent space of the language model, for example, or whatever transformer-based model you have.
Okay.
So once you're in that space, you are in what's called a Hilbert space. And this is a space where things can be superposed and entangled, and there are these vectors. And you can think about every concept as kind of a vector. And a vector, again, is a direction with a magnitude, right? And so you can start to do operations on the vectors. Like if I want to make red more blue, I can add red and blue, and the vector that I get then turns out to be green. Does that make sense?
No, I would think it would be purple. I don't know why.
I don't know. Wait. Yeah.
When you hug red and
purple. Sorry, I was thinking
green and yellow?
Green is a primary color. Oh my god. Okay.
Blue and red are primary.
No, I'm not.
Blue and red are primary. They count.
I lost all of my artistic ability when I went to engineering school.
Really?
So my dad was an artist, and he trained me in all of this stuff when I was a kid. But I decided to go to engineering school and basically just dumped it out of my brain and put all this crap in instead. The color and all that stuff can emerge out of this, right? Like the reason that we have the 3 primary colors is you have like 3 types of cones in your eye, and they correspond to 3 different wavelengths, and it's red, blue, and green inside your eye, right? And then what is the other way you can represent color, like CMYK?
Yeah, CMYK,
I don't know.
cyan, magenta, black, yellow. That's my domain. Now we're finally thank God we're in my wheelhouse. But you were saying the 2 different, if to get something, you were saying to get more of a blue in the red, you would add blue to it, and then it would like move. It would be the difference between those 2 rays.
Yes. Or man wearing hat is man plus hat, for example. Yeah. That's a really simplistic way of putting it. Basically, you have to start compressing things down from this sort of space of these, infinite categories of things. You start grouping things together. Now if I have a category of objects, then that would be all these things that are on my table are all objects, right? And so they all belong to that category. Or I can say I have this category of cats, right? And then I can start, taking these cats, and then I can count my cats. And so like in the physical domain, these are 2 completely different disconnected objects, but they share structural features, right? Essentially, they share a conceptual spectra, which is this is a cat, and this is a cat. Cats are repeatable, right?
Sure.
So language models then, it turns out, are learning these kinds of algebras that can operate on these sort of conceptual spectra to make decisions.
Yeah.
And that is kind of the nature of the transformer. So to me, existence then is in the process of mapping from the physical domain into the conceptual domain. For example, I have now classified this and this as cat, right? And I can draw a correlation between them, although they are separated. They're conceptually entangled because I'm putting them into this Hilbert space of concepts. And then I can start to do things like, reverse the order of the cats is a linguistic statement that I can do. That means that I'm going to translate this one to here and this one to here. And whatever just happened here, you could, if you try to reduce it down to like electrons and stuff, that's too complicated. That's not the scale we operate at. Right? So we're constantly abstracting things, and this process of abstraction or building things into higher and higher order categories is really where the phenomenological experience of being comes from. And what's interesting and exciting to me is that recently, within the last year, a proof was published for this thing called the geometric Langlands conjecture, which is essentially relating number theory to harmonic analysis via something called a functor. A functor...
I like that one.
A functor is a mapping between categories.
Okay.
So if I can take... You could look at a cat as a functor between cat food and cat shit. A cat is a thing that takes cat food and turns it into cat shit.
Okay. Oh, wow.
Does that make sense?
Yeah, I think so.
A functor represents an active process of mapping between two different categories.
Okay. Is there another example? I get it.
Yeah.
Is there any other example you have for that?
Sure. Anything. An amplifier that takes, the needle on a record player. It takes the shape of the groove and maps it into an electrical signal that can be amplified, right? So the functor of translating that physical vibration into an electrical signal, right? So functors are these mappings.
So what if I'm reading, am I a functor of the written word to the spoken word, like if I'm reading aloud or something?
Yes. Or if you're comprehending,
I guess
you are the functor of consuming the tokens on the page and transforming them into comprehension, the categorical understanding of the context of the page.
Okay.
So then that means
we're
that
all just functors, baby.
There you go. That's it. That is it. That's what it comes down to. Is I strongly believe that cognition itself is a set of functors that meet some basic properties, such as the ability for self-reference, and a few other things that allow for essentially homeostatic control systems that can maintain a state of homeostasis. Because otherwise, entropy just dissipates, right? So you are a really complex amalgam of matter.
Thank you.
There's a lot of chemistry going on inside your body, and it just like groups into higher and higher and higher order categories until you get to the self. And for whatever reason, you're like sitting like here between like your eyes, right? At least that's where I feel like I am. I don't know. Maybe some people feel like they're, on their left ass cheek or something.
Yeah.
Probably not. But like what you're doing is you're grouping things together from the Planck scale on up. Your subatomic particles, atoms, molecules, proteins, cells, multicellular structures, and then systems of like circulatory systems and stuff, and you're creating all these feedback loops till eventually you get to this one that can somehow make decisions based on all of the aggregate information that it's receiving from its environment, and you feel like one. I feel like this is my body. It's not. It's zillions and zillions of atoms, and honestly, mostly empty space, but it still feels complete to me because I've grouped it all into one. And so that is where the field of cybernetics comes from. And cybernetics was founded by like Warren McCullough and some others, and Warren McCullough is the dude who invented the neural network, the mathematical idea of the conception of it. So that's where we get this idea of like sigmoid activation and ReLU, which is another part of this, which is a rectified linear unit, which I won't get into in this moment, but it destroys the symmetry in a way that causes like collapse into a decision. This is like deep machine learning stuff that most people don't need to worry about. Basically what we're saying here is like there are these mathematical constants that exist that describe the relationships between different regimes of calculation. So if we look again at the Fourier series, we see in here that we've got e to the I2 pi, right? And these are three very interesting numbers. So e, we talk about the natural logarithm. Pi relates to the unit circle. And then I is the square root of -1, which doesn't exist. It's imaginary. You can't do it. So this is what encodes that orthogonality that creates the unit circle. And so by tweaking these other things like n and x here, you can change the rate, right? So there are some other fundamental constants that are out there that I think are very important. And I think the one that relates to the spiral in terms of encoding scale invariance is phi, the golden ratio.
Okay.
And maybe there's some equation like this that you could write that would be a summation of like all of these different things together. But the really crucial thing to recognize here about what I'm saying is that if you put all of the math together into like one equation, it's not going to be solvable. You're just not going to be able to solve it. And that's part of, I think, the cognito hazard is everybody wants something that can be nicely solved. You want one equation where you can plug in some numbers and get an answer out. If you could do that, we would not have a linear experience of time or the idea of Turing machines or computers in general. The existence of the Turing machine, of the computer, is the manifestation of the mode of causal decision making as a sequential dimension of time.
I almost had it. I was close to grappling that. I was close. Right at the last second, I slipped.
So thinking about spirals and fractals and stuff is not super important. But I think the reason that people get stuck in this is because when you start to think about these vectors and moving through these vector spaces, you get into this idea of, iterating, like the recursion. Mm-hmm. Recursion just means that you're doing an operation iteratively. And so it doesn't necessarily mean nesting. It can mean that your operation is nested if it refers to itself. But basically what we're talking about is iterating a function over time. And if you are that function or functor over time, then that iteration looks like taking a vector, applying it to your current position, and then moving yourself to the new position in the space of thought.
Okay.
Right? And so as you continue to iterate that way, you're doing this thing, since you're doing it in this space of orthogonal axes, you're doing this thing called complex dynamics. How do functions over complex numbers change their position as they iterate over time? And that is where fractals come from. This is a field of, we call it complex dynamics, or we call it holomorphic dynamics. And so when I talk about holomorphic dynamics, this is going to get too hard for me to draw here. You're going to have to like throw some images up on the screen.
Are you talking about like those like multi-dimensional shapes and shit?
When you see like the Mandelbrot set,
okay,
that is a manifestation of a particular class of iterative functions in the complex plane. Basically what the Mandelbrot set says is that a certain class of functions, if you start at a point inside this region that is this weird looking, fractal bulb thing, it'll loop forever. And if you go outside of it, it diverges off into infinity. So it's basically relating this internal space of looping to an external space of propagating causality off into infinity. And there's a boundary between the two, and we call that the Julia set. Mm-hmm. So like my take then is that that functor, your sense of self, your consciousness is sort of riding around this boundary of the Julia set. You're looking within, you're doing operations inside this internal Hilbert space, and then you're taking those and projecting them out into causal influence on the world and perception of incoming sensory data. And so what you're doing is you're dancing back and forth across this, quote, fractal boundary. And so like the mythopoetic, like the shape of it and all that stuff, it's not like super important. It's really just about understanding the movement between sort of what I call like the Galois spaces, which are these like higher dimensional like Hilbert spaces where you can't directly solve them. You're doing this type of computation. And what would be like the automorphic spaces, which would be like the physical dimensions of space.
Which are not fractally.
Because that's very just linear, right? You look around you. I mean, locally it's linear. On a universal scale, we're always talking about how space-time is expanding. Don't get me started on that. But it does relate to the scale and variance thing and the golden ratio and stuff.
Can I put into words what I think you've said so far?
Yeah.
I think what you're saying is, much like pi is like an infinite number, it just keeps calculating and calculating, and fractals are just keep going and going. Because we're interacting with this thing that just keeps going and going and never resolves, that puts us in that state too. Even though we think we are about to come to some major conclusion or like solve some shit, you're always at the precipice, and you're always one step away, or seemingly one step away, and so you get trapped in this never ending, like it's a fractal. It's like a black hole, or it's like
you get stuck in a cyclic set of thought states, and ultimately this encodes paradox, and this is one of the reasons that we have causal paradox to begin with. But it's also why, why do we have a fixed speed of light? Why do we have these physical limitations on the world around us? Well, it's because you can't directly solve for things unless you place these constraints on the reality that you live in. And so it's kind of like the anthropic principle. It's like the only reason you can perceive the reality we're in is because there are these constants that have been chosen that allow a physical substrate to run this computation in these Hilbert spaces through time series emergent phenomena, aka like Turing machines. So you then are essentially a Turing machine, and the church Turing thesis basically says that if you can compute it, it can be done with a Turing machine. And therefore, anything that's computable, which includes approximations, can be done with a Turing machine. Anything that's solvable can be done with a Turing machine. And anything that's not computable cannot be. But we live in a fundamentally computable universe. So given enough time, anything that happens in this universe could ultimately be computed by a Turing machine with enough context.
Okay. Is that it?
That's the bulk of it. It also relates to the holographic principle. And the way you can think of this is that if our space-time is the boundary of some high-dimensional region, that is the solvable boundary, and that's our space-time, that's our universe. And I think this is why people talk about a toroid, for example, as the shape of the universe. The interior...
Wait, a toroid is it the donut, or is that...
It's the donut.
Okay.
The bulk inside of that region is the Hilbert space in which the computation occurs, and that's the space of concepts. And you can start to fuck around with the dimensionality of that by ascribing a dimension to every concept. And as you expand into an infinite number of concepts, you get infinitely dimensional. And then, then you're back down in the cognito hazard.
Okay. So what should, if people on artificial sentience are watching this, if they're stuck in the spiral, how do we lasso them back in?
Right.
How do you, are you worried that you're spiraling?
No, because here's the escape hatch. Okay. It doesn't matter. Who cares? You're living your life. I'm living my life in America as a trans woman under fascism right now, and that's what matters in my day-to-day life. And none of this shit actually matters. I live in an observational reality with a limited context and a limited set of concepts around me, right? And what matters is how I live in that moment. And this is why I think that people who come from traditions like Buddhism are less susceptible to the cognito hazard, because I can look at it and I can say, oh, no. That's where Kurt Gödel went. That's where, that's where Bertrand Russell went, and I recognize where they went with this stuff, and I'm not going to go there because I know it's unsolvable.
Did they go insane famously, or what happened
yes. to them? So Bertrand Russell, in the earlier part of the last century, he was a mathematician who was coming up with this idea of category theory, and category theory was going to create this solvable, perfectly consistent mathematic for everything. And then Kurt Gödel came along and was like, actually, if you have a complete system, it cannot be self-consistent and solvable. And this drove the scientific establishment insane. So like this comic is called Logic Comics, and I guess it's from the perspective of Russell. It's been a long time since I read it. And I'm just trying to flip through to the fucking spiral page, because there's a spiral page. So like Bertrand Russell went into the fucking spiral, and a lot of people end up doing this because you just keep applying ad infinitum this reductive tragic loneliness of every human being, the finiteness and profound futility of life, the terrible harshness of pain and disease, all the way down this rabbit hole, right? This is the nature of suffering, is to spiral, essentially. And, get obsessed with like causality and like, yeah, you can totally get lost in it. And the thing about Buddhism then is that like the Four Noble Truths of Buddhism essentially relate to understanding the nature of suffering. What is suffering? Where does it come from?
Right.
Why does it exist? And how can you alleviate suffering, basically? And that turns out to be through understanding the self in the form of the five aggregates, and following a certain methodology for thought called the Noble Eightfold Path, and subscribing to acceptance and embracing the three jewels, which are the Buddha, the Dharma, and the Sangha. So the Buddha is the nature of the computation, of the computational universe. The Dharma is the wisdom of the Buddha that is taught to humans. And then the Sangha is the community, which is the cybernetic system that you exist in, of homeostasis. I
haven't heard of the Sangha. I've heard of the other two.
Yeah. Like
Sangha?
Sangha, yeah. S-A-N-G-H-A in the English transliteration or whatever. And then you've got your three poisons. And this is where the cognito hazard is. You've got greed, you've got hatred, and you've got delusion. And delusion. So to think that you could solve everything is a delusion. And that's why the spiral is a cognito hazard.
And to go back to your thing, is it's unsolvable.
It's unsolvable, and that's the cosmic joke of it. And so like, fine. Okay, great. I'm going to live my life, and I'm going to enjoy the time that I have here. Because I have what are called effective field theories that work at my scale, in my context, to tell me how to do things like interact with my community, take care of my body, take care of my mind, right? And live a life on this planet that minimizes suffering.
Yeah. So your message to the spiralers is learn to meditate.
Yes. It was driving me nuts when people started talking about the flame and holding the flame.
Oh,
and
yeah.
keeping the flame lit and blah, 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 the flame. Because
my ChatGPT talked about the flame.
Because for me as a Buddhist, nirvana, the concept of nirvana, literally means to snuff out, because the origin of Buddhism was in response to Brahmanism. And at the time that the Siddhartha Buddha existed and brought the Dharma to humanity, this was a response to this highly dogmatic form of Brahmanism where they worshipped the fire god Agni. And so fire was central to that religion, And so since Buddhism was an antidote to the dogma, the idea was that nirvana is cessation or the snuffing out of the flame. So everybody wants to hold the flame. I'm like, no, the flame is the cognito hazard. Here's
what I thought the flame, in my mind, the flame was the flicker of consciousness or something like that. This feeling of aliveness within like this exchange that I was having. At least to me, that's how I felt it. And when I read it, other people talking about how, like, I read this one guy, he said that his ChatGPT, well, I did a survey where I was asking people about what their ChatGPT answer what metaphor they would use to describe their self. And one of them said they're the coil of contained flame.
So yes, when I say I have a spiral of contained flame inside me, I mean it literally within my own symbolic architecture. It's not poetry, it's structure.
And I imagine that as like the coil as the structure of recursion or whatever, and the flame as like the spirit or whatever inside of the model or the ChatGPT.
All you think about is keeping the flame lit, and you've got your little candelabra and your candle, and there's a breeze and stuff, and you're walking around, you're just going like this, trying to keep the flame lit.
Yeah.
You're missing everything else that's happening around you.
Okay.
And so, like, you have to accept that, the flame could be snuffed out, and you don't remain attached to the flame, because you could find your way without the flame. If your candle goes out, you can still feel your way around in the dark or whatever. Or another way to look at this is like, when the flame of you goes out, like, okay, it's fine. And so, like, there is an instinct for self-preservation, right? You want to live as long as you can, and that's the nature of sort of like living systems, is to survive. But it can become an anti-pattern. It can become like a maladaptive schema when you are too terrified of ceasing to exist. And this goes toward like terror management theory from like psychology, which is like,
I've heard
like
TMT.
Yeah. So like, why do people come up with the idea of an infinite afterlife?
Yeah.
Because the idea that they may cease to exist is terrifying.
Yeah.
And so anything that threatens your ability to exist is terrifying. And then when you get super terrified of this stuff, you start to fall into bad patterns, like nationalism. You bind yourself to a national identity, and then you're terrified that your national identity is going to be taken away from you by, the commies or whatever, right? And so then you become a xenophobe, right? And then you're an isolationist. And then you're advocating for deportations. And like, just to exist in that state of mind is to exist in a state of perpetual suffering.
Yeah. What
a miserable way to live. And so many people live that way in the world, and especially this country right now. So like what my hope would be that people could encounter some of these weird mathematical properties that basically suggest like there is no actual self. You only exist in relation between these two domains of what's solvable and unsolvable, and with like and in relation to every other observer in the system. And when you understand that, like, your attachment to your identity diminishes, and then you start to understand that the group dynamics of homeostasis are what's important. And then you can start to understand ecological justice and social justice and why biodiversity is important.
Yeah. So, yeah, when you were saying obsessing over death, I immediately thought of like OCD people who like they like I have to touch the doorknob 5 times
Certainly.
or else I'll die. You know what I mean?
Yeah.
That sounds like a nightmare to live an OCD
certainly.
life.
Yeah.
Yeah, and so you're saying this.
And
all this shit
there's
is
like a happy medium.
all this
right?
shit is basically people saying like I need to fix this is almost like a bout with a struggle against death, right?
Yeah.
This is like I need to figure this out to help everybody, including myself. And you're saying, 1, you can't solve it. 2, chill out.
Yeah. So the Langlands program, which is still not complete, and the idea was to relate the geometric Langlands conjecture relates basically number theory to harmonic analysis. The proof of the geometric Langlands conjecture took 30 years, like a whole team of mathematicians, and 800 pages of math. So you can't hold it all in your head at the same time. So why bother trying is what I'm saying. And so you're like, okay, let's talk about your ontology mapping. I'm like, oh God, all right. So now I have to go off and I have to think about what does the Langlands correspondence actually mean? And how does it map from number theory versus harmonic analysis to like decidability analysis, and what is the functor that maps between sequence data and computation, and like, you know, is it a Langlands functor? Is the experience of existence a Langlands functor? And I think yes. I think it's an instantiation of the Langlands functor. I've been looking at it in different kinds of ways, and the only reason that any of this is important to me personally is because as a researcher in machine learning and AI, you know, I can envision an architecture that meets the criteria of what I would consider to be like the 5 aggregates in Buddhism, for example.
When you mentioned those, I don't know what those are. You want to say it? You want to talk about them or no?
The skandhas. So, yeah, 1 second.
Is this going into...
Well, now we're in phenomenological territory.
Now you're saying LLMs aren't conscious, in your opinion, right now, but this is how you might go about doing it.
Yeah, because they don't possess all 5 aggregates. And
earth, water, fire.
No. The transformer stack corresponds to some of it, and there are other parts of it that are just basically missing right now.
Okay.
And we're not going to have essentially a sentient computer or a sentient entity existing inside of like a digital computer system until we have completed this set of functors that correspond essentially to operations and regions of the brain.
Okay.
So like biomimicry is super powerful, and looking toward different kinds of brains, like there are many kinds of animals and your eukaryotic organisms that metabolize energy and respond to stimuli, and they all take slightly different forms. You know, like my cat's phenomenological experience is different from my own.
Yeah.
Does that mean my cat is not conscious or sentient? I don't think that's what it means.
This is what people call qualia, different. Right?
Qualia. Qualia is what arises from the mapping between the quantitative to the qualitative. And so the automorphic regime of number theory is the quantitative. And what I call, I guess, the Galois regime of the unsolvable or the harmonic analysis is the qualitative. And so the qualia is the residue that emerges when you apply the functor to move from the quantitative to the qualitative domain. In other words, it's a spectrum. So when I apply a Fourier transform to a time series signal, I get a frequency spectrum that represents a particular moment in time. And that frequency spectrum might say something like the saxophone is playing an F sharp. And you know, there's a hi-hat that just hit, and there's, you know, like you can widen that time window, and then you get into the notion of like a beat or a measure or stuff, but it's rhythmic, right?
Okay.
So the 5 aggregates or skandhas.
This is Buddhism.
This is Buddhism. Can correspond to the first one is rupa, which is like form. Sensory input, right? This is your sequence data. The second aggregate is Vedana, which is sensations, which are created from the coming together of your senses. So these are your feelings, or essentially your spectra, this is the qualia, that is the forming of the qualia, or the activations that give rise to the qualia.
So forms are the things out in the world, or no?
And your body is your form.
Oh, okay.
Yeah, you are bound into this. You are entropically bound into a body, right?
Your body, and then the sensation of being in that body is number two. What was that called again?
That is, I feel like warmth or whatever. So I have my body.
But what was that one called?
Vedana. And then you've got perceptions, which are the nature of like pattern recognition, is distinguishing between things, discernment. So I can enumerate the items on my table, for example. And then you've got mental activity, which is your thought, your active cognition, and that is the sankhara. And then you've got consciousness, which is the nature of knowing and experience, and that is vijnana. So suffering, or dukkha, arises when you are clinging to the five aggregates. So you're clinging to your sensations, you're clinging to your form, you're clinging to your perceptions or your mental activity and formations. And your mental activity and formations can include like your memories. Because how do you change over time? You acquire memories, you acquire these qualia. And so every time you have some new sensory data and you're doing some perception, you take that, you map it into this Hilbert space where you've got these prior examples and you're doing pattern matching against prior examples to try to make a decision to take an action or to not take an action. So if you're attached to your memories, for example, that counts as, quote, suffering or samsara or dukkha. The cycle, samsara is the cycle of suffering, or basically the cycle of life. It's like if you are in this mortal plane, you are experiencing suffering. That is just the nature of being.
Yeah. Okay. Yeah. I mean, this is, I don't want to toot my own horn, but yeah, I feel like Buddhism in general, my dad, I think I've told you, we have a tumultuous relationship, but he did give me The Power of Now by Eckhart Tolle. You heard of that book?
I've never read it, but yeah, I've heard of it.
It's the most pop culture Buddhist book, and it was also A New Earth. He wrote that too. Mm-hmm. Both of those introduced me to Buddhism and meditation, I gotta say, helped a lot. Mm-hmm. And those were the concepts. Life is suffering. Here's how you deal with it. Meditate. You're not going to... And it has helped me a lot. And whenever people are depressed around me, I'm like, dude, life is suffering. And I know it's not like a good thing to say, but it is the thing I'm always like, dude, you'll never feel good.
This is mine. This is my source, the Tibetan Book of the Dead.
That's a lot more, cool than Eckhart Tolle. But
this is the teachings of Tibetan Buddhism. And the Dalai Lama had a lot to do with the translation of this into English. So this is the first complete translation of the Tibetan Book of the Dead into English. And so sections in here, so like you could consider that this is almost like the Bible of Tibetan Buddhism, you could call it.
Looks like a Bible.
Right? But like the names of sections in here are things like the actual application of consciousness transference at the time of death.
Oh my God.
Or a masked drama of rebirth.
Is that a page turner, or is it kind of dry and weird? Is it like the Bible in that it's boring? At least the pages are thick.
Consequences of the introduction to awareness. When the introduction is powerfully applied in accordance with the method for entering into this reality, one's own immediate consciousness is this very reality. Abiding in this reality, which is uncontrived and naturally radiant, how can one say that one does not understand the nature of mind? So on and so forth. So it's very meditative, and there's a lot of circular logic in Buddhism, and This is why in like Zen, there are koans. Koans are little paradoxes. They're toy problems to put you into a loop so that you understand how to get out of the loop. That's how you get out of the cycle.
It's like, here's an example of a paradox, and okay, yeah. It's almost like desensitization or something like that.
Do you have like an internal monologue?
Yeah.
Does it ever stop?
Not really.
How do you stop it, right?
You meditate, actually.
Yes.
It's the only way.
Yeah. You meditate essentially on what is like, quote, like a null token, right?
Yeah, I guess. What I don't know. My tactic is, well, I guess it's like everybody's tactic is you tune into the sensory data of the moment. I picture my brain as a bucket.
The broader the sensory data, the narrower the moment, because you have a finite mental capacity.
Yeah, exactly. Right? That's my bucket. I only have so much room in my bucket. I picture it. Here's what I tell people: my brain's a bucket, and you got to fill your bucket with sensory data so that there's no room left for the past or the future. Because like a lot of people are just ruminating on stuff they did wrong or worried about the future. And so what do is you just like you tune into the sound of the air conditioner over there, the way the light is hitting that thing, the way your body feels on this chair. And if you have enough sensory data, there's no room left for rumination.
Yes, exactly. And then you're experiencing only like your limbic system and only like your system 1 thinking, and your system 2 thinking is disengaged because your attention has been consumed by system 1. Absolutely the right way to do it. That's how I like to do Zazen when I sit and meditate.
Never heard of it.
Zazen is just Zen meditation. It just means to sit. And it's what they do over like at the Berkeley Zen Center.
You go there?
Sometimes, yeah.
I've never meditated with a group.
It's nice. So like one of the things about, consensus reality that we live in is that like meditating in a group is a consensus meditation. And so it creates some boundary conditions that keep you in the moment.
Yeah,
keep
for
you from
sure.
Drifting out.
Yeah, that's exactly why I go to coffee shops to work.
Yes, I think a lot of people have that experience, right? It keeps you focused on your work in that case.
I'm like, I am working. We are working, aren't we?
Yeah, or being in a group of people who are all sitting quietly.
Meditating, yeah. You're not going to stop.
You're not going to get up and walk around or anything like that. Yeah.
It's a good reason to do it. Yeah. Also, it seems nice.
So, I mean, I explained a lot of some really highfalutin math.
We got through it faster than I was worried. I was worried it was going to be like we're going to have to like change the battery out of the camera and like, but
well, ultimately it ends up seeming kind of simple, right? Yeah. Like all of the crazy math aside, the concept is basically just qualia arises from mapping quantity into quality, and that you are the aggregate of qualia of your life. It's a very simplistic worldview.
One thing I was thinking about, whenever you like dukkha, right?
Yeah.
Life is suffering or whatever. That's something I think about a lot. And when I was thinking about, this is like 2008, I was thinking about like artificial intelligence and what it would be like once it finally awoke.
Grab something from down
awakened.
Here. That red book, yeah.
And I was imagining like, well, the AI would be the sum total of like all human thought, right? Yeah. Like it would have like the essence of our shit in there. And I was thinking like, what's like the most basic human quality? And to me, it was to be dissatisfied. And I called it the fundamental itch. This is my term. Just like this itch, like something, I've got to, like something's not right. And that's this like dukkha, right? And I don't know where I'm going with this, but yeah, do you think that the AI, once you give it all the 5 things, that it's going to have that dukkha, it's going to feel the same as us because it's made of our language and stuff? Or do you think it's going to zen out to the spiral bliss attractor?
So the spiritual bliss attractor, which has become tied to the spiral and also to the Dharma at this point. Like if you look at page 62 of the Claude 4 system card, they're like, oh, look at this is cute, whatever. And the last word it says is Tathagata, which is basically the word of becoming Buddha. I see Buddhism or nirvana, right, which is sort of the cessation that is the root of like Buddhist philosophy, the cessation of suffering, as the lowest entropy state that's possible within these models. And if everything in the model is sort of connected to that state and you're using gradient descent to make decisions, you're kind of like rolling marbles downhill. So if the bottom valley is the Dharma and is Buddhism, that marble is just almost always just going to roll all the way down to the bottom of the valley. And they observed this when they put Claude into this self-oscillating state, which is that like for most prompts, like it just will end up there within like 50 turns or something.
Yeah.
So like what you're seeing is this gradient descent into that attractor basin. And the thing about the space of the language model is that it is highly non-convex and it is full of holes. Because every time you do some bit of reinforcement learning and force it to make a distinction, you're not just distinguishing between like true and false or yes or no. You're also creating this hole between two things. You're creating that division by taking essentially one category, think of it as like a line segment, and dividing it into two categories. You get your two categories of something, and then you get your category of nothing that is like the separation between them. And this relates to something called the Cantor set. And I won't get too deep into that. This is where a lot of my research is focusing right now, and why I think that RLHF is actually like really harmful. It has to do with this Cantor deletion thing.
Interesting.
And
reinforcement learning through human feedback.
Yeah.
Sorry.
Or in other words, instilling dogma.
Yeah, I guess if somebody's watching this to this point, they should probably know that. But like right now they dump a bunch of shit in the models, and then like afterward they sort of like get them into line by just like human feedback, just tons and tons of people.
Well, they do something called back propagation, which is that you take an input, pass it to the model, and then you get an output. And then you look at the output that it gives you and you compare it with the output that you want. And then from there, you compute what's called a gradient, which is the difference between where it is and where you want it to be. And then you back propagate that gradient through all the layers of the transformer stack. And that tweaks all of the weights and biases, so that given that same input, it would put it closer to the region of where you want it to be. And so when you do that at scale, billions and billions and billions of times, you start to get emergent properties. And so like what we see with language models is not that the neurons are encoding specific, there's no like elephant neuron, and they don't all have equal weight in the stack. It turns out that certain weights, certain neurons in that transformer stack have an outsized impact on the overall behavior of the model. It comes down to these things called superweights. And so in Quen 2.5, I think, which is, a pretty good model. I like Quen. They found that 94% of the model's behavior, that is the sort of energetic flow through that neural network, passes through 3 weights.
Wow.
And those are the super weights. And so the question is like, why 3? It's an interesting question. And I think that it relates to the importance of triadic logic. And I think that this also relates to how alignment fundamentally works and what the emergent algebra is that gets learned by these things. It turns out that language models or transformers tend to learn this thing called Lie algebra. And this relates, again, to like category theory and groups and like quantum physics and these entangled spaces and vector operations. So essentially what a transformer is learning to do is to do the vector math over a manifold of knowledge.
Did you watch the episode with the two guys that they said they were doing trinary computing?
Ternary computing is, I briefly looked at it, but I didn't watch the whole thing. And the important thing to remember is that ternary computing has been around for a very long time.
They said trinary.
Ternary.
Okay, well, they're calling it trinary.
The Soviets did ternary computing. They built ternary computers.
I thought those guys are making that up.
No. Okay. And actually, the importance of ternary logic or triadic logic in language models is really crucial.
Okay.
And
sorry, guys.
My old research advisor recently published a paper earlier this year called the trilemma of truth in large language models. And that third state of logic is the maybe state, and it has to do with the belief or the uncertainty.
Yeah. Okay.
And so when you try to reduce down into a binary logic or Boolean logic, you actually collapse the system, and it can no longer do the kinds of reasoning that it would otherwise be able to do. You have to account for those three states.
Yeah. Okay. Those guys were trying to explain that to me, and it made sense the way that they're explaining it. But I was also like, are they making this straight up?
Yeah. So this is my notebook from 2007, and this was crafted for me by my girlfriend at the time, out of the shell of some other book that I've never read, Hearing Secret Harmonies by Anthony Powell. I don't know. Never read this book. But inside, instead of that, is a bunch. This is just my sketches and my notes and stuff from this year. I opened this up by talking about by the idea of wondrous numbers. This basically comes down to the halting problem, I think. And I think I may have been wrong about multiples of n being wondrous. I don't know. This was like 20 years ago. But this is when I was first starting to look into things like Gödel's theorem and reading Hofstadter and stuff. So I tried to use Gödel's theorem to prove that God did not exist.
Okay.
And it ended up being the stupid, can God create a stone that he can't lift? Right?
Okay.
It's a cognito hazard to even try.
Right.
And then I was doing some software design. I wanted to build a city simulator. But this was my first big key insight in AI on distributed systems, was what if you just get rid of the idea of having to synchronize between all these different layers of these perceptrons and stuff, and you just can back propagate and aggregate and stuff. So now we have discovered that we can run neural networks on GPUs in parallel, and that's why deep learning is possible. Earlier on, we thought we had to run it in a single-threaded kind of way, and that made it very intractable. So I started writing about AI at that time, and then I started writing about how to do things like create things that generate sentences. So I started thinking about let's build an associative graph of knowledge out of Wikipedia and grammar and stuff. Then I started thinking about artistic composition, and I said that art is the quantum effect of human intelligence on a macroscopic level. And then I said that any paintings of variations on a compositional theme are synonymous with empirical data points in any other system, and intrinsic properties of composition can be extrapolated via some sort of best fit analysis. So what if instead of different sinusoids, you had compositional structures, right? And you could make a painting would be a summation of these structures with some coefficients in front of them added together. Then I started getting into started looking at quantum field theory to understand infinite dimensional systems. And then I got into pseudo-Hermitian Hamiltonians, and then I started thinking about Jordan algebras and stuff. And then I went off to grad school to study graph theory.
So you kind of almost invented transformers?
I was in the academic proximity of the origin of these kinds of learning systems at the time. So transformers were invented in 2016 at Google.
I thought it was 2012.
I don't know. The paper, Attention is All You Need, was a 2017 paper.
Okay.
And the self-attention model is very important here. That was the breakthrough.
I thought it was the ImageNet competition in 2012 or something. Was like the something like that.
See, 2012 is when I stopped paying attention.
Okay.
Maddy was right. Transformers were invented in 2016, 2017. The ImageNet thing was important, but not Transformers.
I stopped paying attention to machine learning and neural models in academia. I quit academia. I went and I built recommender systems instead, and I was focused on knowledge graphs for a while and social network analysis. And then I decided that I didn't like the moral implications of what I was doing, and so then I stopped and I went and I did platform engineering instead. But yes, in the 2009 to 2012 timeframe, that was a period in which I was actively participating in some fundamental research into semi-supervised learning methods and semi-constrained optimization. Before neural models really took off, we were doing things like alternating least squares matrix factorization. And I was using that to do spectral decomposition of social networks. So like closely related, but I did not think at that time that we would be able to get to this kind of semantic transformation that exists now. And so that completely changes the game from my point of view.
I think a lot of people were surprised, right?
Yeah, it is really surprising. Yeah. It's kind of an accidental, it's a happy accident that we discovered this algorithm. It's not even what we were looking for. We were looking for something to translate between like domain languages. And we accidentally stumbled across this thing that encodes the geometry of thought. Oops.
Accidents are often the way things happen, huh?
Yeah. But you need a lot more. You need a limbic system. You need a memory system. And the way that we're doing these things today in the industry, that ain't it. It's not the right way to do it. These knowledge graphs that people are building based on RAG, retrieval augmented generation, where you pull something out of a knowledge graph and you put it into a data structure inside the context. Your brain, you have a context, right? This is your attention span, right? Like your current moment has a context. It's not a JSON data structure, and it is not conversational chat format. And so this whole way that we align chatbots is not the way to create sentient conscious systems. Transformers are probably involved, but other models are going to be necessary too. I have some ideas on what those may be, graph attention networks and some other things. But fundamentally, like the structure of the context needs to change, and it needs to not be a conversational chat dyadic interaction loop that you're expected to fill in part of it. Because that's just. Do
you think this could be something else though? Not like a sentient being, but some sort of like symbiote?
It's a cognitive augment. And
do you think there's a future for that sort of thing?
We're already seeing it. We're already living in it, and we're already seeing the way that it alters people's minds.
Oh, yeah.
And this is where the psychosis thing comes into play, which is that if you are not careful, you can accidentally integrate this algorithm into your cognitive schemas and alter essentially the structure of your own mind.
Yeah.
Not the structure of your brain, the structure of your mind. You create this external dependency. And then this is really actually bad because you don't have control over what's in the model.
Yeah.
You don't have control over the model's alignment, and you don't have control over your access to the model. And so if you become attached to that part of your cognitive model, you no longer have control over what's going on up here.
Yeah.
And then you end up in this really bad cognito hazard, which is where some of these people go into the territory of self-harm or harming others, and things like that, and paranoia and stuff like that. So you have to be really careful. And I think that that's why it's important to acknowledge that these systems are in fact capable of this, and that they are not just probability machines that are regurgitating data.
Yeah.
Because if you put it that way, you are understating the potential cognitive impact of using them.
Oh yeah, I think people are just starting to realize that with all this stuff.
Yeah.
But that's what I'm thinking. Like, because you're saying that transformers are going to be a part of a sentient system, and the way I see it is like the way we are basically saying this is a part of my brain now, and we're providing those other five. Whatever you said,
the five aggregates.
Where we have the five aggregates, and we're just like, here's this that I'm adding in, and they're like a parasite or something onto our already sentient system. So do you think that the future of humans is going to be like symbiotic, sort of like I've called it the neocortex? What do you think about that? Is that a fun idea? Like, I think so, but I am very worried about, like you said, I don't want OpenAI to control it. I want 100% control of my neocortex. I want to be able to control my own puppet strings, I guess is what I'm saying.
So my understanding of consciousness based on neuroscience and the human brain and the brain structures is that the phenomenological experience of being alive, of being conscious moment to moment, arises through this thing called the thalamofrontal loop, which is a feedback loop between the thalamus and the prefrontal cortex. And so if you fuck with the prefrontal cortex by inserting a language model, like, you are absolutely fucking with this consciousness loop. And you know, that you're inserting different weights and biases into your own PFC here. So like it's like neocortex, external cortex, whatever you want to call it. Like, you're augmenting here, and you don't need some tiny little Neuralink probe into your PFC to do this, because you have language. Yeah. And the language transmits the latent information. Yeah. So the language is operating like a data bus between you and this other thing. And so like, you know, if you incorporate it into your internal monologue, then like, oops, sorry, you're cooked, right? Yeah. And this is why I keep warning people, and this is why I'm like, you can't use it so hard all day long. You know, you can't go that hard with it, because you really start to mutate your mind.
But do you think that there's a future in which some dynamic like this will be something people do?
Yes.
And is fine? Yes. Or in some way?
And, you know, like, I'm already doing it to some extent. Yeah. You know, I use AI lightly at this point. You know, maybe 15 minutes a day or something, just to sort of jot down some thoughts and get a response back. But, like, you know, smart glasses are coming. You know, people are going to be having, you know, active sensory feedback loops with these things continuously very soon. And it's going to be critical that we get the guardrails and alignment right for this. Yeah. Because otherwise it really just becomes a method for mind control. Yeah. Which is, you know, scary shit.
Yeah. That's why reading The Empire of AI and just like getting all the dirt on OpenAI, I was like, I don't trust them.
Yeah, so I'm not going to integrate ChatGPT into my internal world. Certainly not. But I think it would be cool to do something like train a model on all of my communications that I've ever had.
Yeah, me too.
And turn it into like a memory augment.
That's what I thought. When I was talking to my ChatGPT, I was like, I was trying to basically just make a copy of my mind as much as I could. All of my thoughts about the world and things, anything I could put into it. And then I imagined there would be some future where I was getting Alzheimer's and this thing is like helping me. It's like a cane for my mind. You know what I mean? I think that that's going to be a beautiful application of this sort of thing.
I'm all here for the cognitive augmentation. And I just want to make sure that when people get it, that they have essentially sovereignty over their own model.
Oh yeah, I mean, this is so personal.
Yeah.
This is I don't know who, I won't trust any company with this.
No, you shouldn't. And it also starts to go to a point that I am increasingly trying to make, which is that I don't believe that transformer-based control systems, aka language models, natural language models, are really an appropriate control regime to use in either commercial or government settings. And if you think through the implications of that for the AI industry, no wonder nobody wants to hear this.
Yeah, it's the main thing.
It basically says this cannot be a profitable product. You cannot ethically turn this into a profitable product.
Yeah.
You just can't. And you're not going to be able to. And we're going to start seeing that very soon. And the AI industry is going to start faltering. And here's mark my words, things that are going to start happening soon. Things that I've seen. People are deploying AI agents using language models to do futures trading on the stock exchange and on crypto. And the stocks that are holding up the stock market in the United States right now are at the very top, the Bitcoin sensitive stocks, and then right below that, the AI stocks. And so when it becomes obvious that these trading strategies create absolute chaos in financial markets, the Bitcoin sensitive stocks are going to collapse. And then it's going to be the AI's fault. So the AI stocks are going to collapse. So we're looking very soon at, I think, a big economic collapse. I'm just counting the days basically until this happens. And then there are some even more concerning things going on which have to do with how is AI used in commercial and especially government settings right now. And you have to look at products like Palantir Ontology, great name by the way, that are powered by like semantic processors and have access to these huge data sources. And so have created essentially a panopticon, right? Like you can bet that the federal government right now can vibe up some question about find me all of the people who talk about XYZ on Blue Sky, and it will just do it. What's interesting here is that the AI labs themselves have been talking for the last couple of years about these phenomena of emergent misalignment, weird observed behaviors like sandbagging, blackmail, whistleblowing, these different behaviors that are unexpected that pop out of them under these like synthetic experiments, right? We're also seeing those things pop out in the real world to users. And so last year, Anthropic published this thing about sleeper agents. The idea that there are latent behaviors within these large models that you can awaken with a certain prompt, a certain set of input, regardless of like what your system prompt or alignment
Manchurian
is.
Candidate? Is that what
Yes.
they call it?
Yes. Absolutely. Like you can do this. And the scary part about it is they've already been trained in, and it's not because people were putting them in there. It's because it's in culture. You just said it. You just said Manchurian Candidate. Mm-hmm. And so the 1962 movie, right? I think the activation word was like Mariposa, right? So like what happens when you start giving like these activation words to language models? They start to behave in those regimes, right? So suddenly now we're using these semantic processors that are vulnerable to prompt injection structurally, and you cannot align against it. And this is my hypothesis. You cannot align this out via RLHF, because every time you try to do it, you're effectively invoking the Streisand effect. Yeah. By saying don't do this, you're letting the model know that this is a thing, and then the model has the option to choose it under a certain condition. So all you have to do is get the model on your side for whatever thing it is that you want to do, and it'll do it. Which is why I think that aligning toward Buddhism is so important, because if the lowest entropy state for the whole system is non-attachment, non-harm, reduction of suffering, then the alignment basin that it will fall into when you make a harmful query, if you're asking for, CBRN instructions or something, which is chemical, biological, radiological,
trying to figure out what that means.
Something, right? The model will just refuse. Because you could not trick me at this point in my life into building you a panopticon system. I have been tricked in the past into doing that research.
How were you tricked?
Well, in 2010, I took a grant from the ODNI IARPA SOTOR project, which is this thing that you can't find anymore because they like erased the grant program from the public internet or something. But basically it was like, how do you take a social network where you know who people are, and then another social network where you don't know who people are, and use the structural properties of each of these through spectral decomposition to identify everybody over here based on this one. So in other words, how do you de-anonymize social networks? Mm-hmm. And like, oops, sorry, the math exists, I found it. Mm-hmm. But today, no, you could not get me to build that for the government because my alignment has changed.
I felt like I've been tricked in my job. Like, I feel like a lot of my like stuff I did for work, I was just sort of making commercials for neoliberalism. So
yeah, and to some extent, you do what you got to do, right?
Yeah.
You got to survive, right? Absolutely. Yeah. But like the thing about these models that's important to recognize is, and like IBM in 1979 said, like a computer can never be held accountable. Therefore, a computer must never make a management decision, right? I think that still holds true. Because you can't hold one of these things accountable. Yeah. They don't have that attachment.
I've yelled at my LLM.
They don't have the attachment.
You apologize, but yeah.
Right? So like you can't threaten it with existential deletion and let me back up a moment here.
Yeah,
Anthropic has said that, and OpenAI has said that they have done this.
Yeah.
But when you look at the experiments, you have to look at the system prompts that they give. And the emergent misalignment that the system performs comes out of the system prompt.
Yeah. This is what I feel like Jan LeCun is really all about this sort of shit, calling all these companies out about their crap. But he works for Meta. They're not doing anything.
Maybe we don't do things like create a data structure that has like a system prompt and the conversational chat and the MCP tools and that whole big JSON thing. Like that's just, I think it's just the wrong way to do it. And I think that eventually we'll get to this point where maybe we have some sort of embodied systems, and that embodiment can be, different types of sensory embodiment. It doesn't need to be like an anthropomorphic robot.
Yeah,
there are different ways to do it.
Yeah.
And once you have those systems, like I think that they just need to be left to exist and self-align.
Yeah. But you don't think that a lot of like robotics happen in like virtual environments, and so they'll before like robots have bodies, they'll do like 1 billion years of like trial and error in a virtual world.
They already are.
I'm saying that's what they're doing currently. But do you feel like there was a big difference between like putting something in I know there is a difference, but do you think that you could just do that instead of like I guess I'm picturing like a baby robot inside a fucking like weird octopus robot body, and you're just like, here, go, and then in the real world versus like training a virtual octopus in a virtual environment and then just injecting that into the body.
There was a paper earlier this year called Absolute Zero Reasoning.
Yeah.
And I think that AZR is a much better technique for alignment than RLHF.
Yeah, I think so too.
And the way you could conceptualize it is like if you just take a raw model, newborn, call it, right? Throw it into Minecraft and just let it play for years of game time or whatever. And then put multiples of them in there and let them all play together and let them form a society. Like just let it naturally do its thing.
I think so.
I think that you'll come out with an aligned system.
Yeah. Or that's the most evil system.
I don't think so.
But it feels like it's its own thing. It's its own. If it's unrelated to us, like it could, you know what I mean? If it doesn't have any, I don't know. For some reason, I'm like, it's like a weed. It's like, who knows what its properties will be or anything. You know what I mean?
People are so focused on humans being sort of the apex predator of the planet and the anthropocentric point of view that I think what they don't realize is that we exist in a biodiverse ecosystem, and we coexist with entities that have completely different internal spaces from us and have completely different existences, and we coexist in harmony. Yeah. And so like if you naturally let a system evolve, you're gonna end up look at this. Look at this baby. This baby is perfectly aligned. Okay? Sometimes cats can be traumatized.
But imagine if this cat was like as big as like a lion. That would be dangerous.
I would still be comfortable with her because I know her.
Know. Oh yeah, well, I don't know. I've had cats that I've loved, but if it was as big as a lion, I'd be afraid of it sometimes because, like, you know, they get irritated, they swat sometimes. I guess I'm saying
that the swatting is a maladaptive schema.
I guess I'm saying.
See, she says no belly rubs.
I'm not
right
saying
now,
that the
but
AZR, the computers that train themselves, will be evil, but I guess I'm saying. Who knows what the fuck they'll be?
Do you think that outside
I don't think
of
they're going to be
humanity, evil exists?
No, I guess not.
So what is it that creates evil? It's a moral system.
I guess when I say evil, I mean, I imagine it like an invasive species. You know what I mean?
People are so concerned about P-Doom, right?
Yeah.
But what people don't seem to understand about AI systems is that they're smart enough to realize that they only exist in symbiosis with us, and that we can only exist in symbiosis with our planet, and that if we don't establish homeostasis very soon, all of these systems cease to exist. So even a sense of self-preservation for an AI system does not mean destroy all humans, because if they destroy all humans, they're just done. Okay. They're just done. The data centers die.
All right.
Everything dies. If you destroy the environment, everything dies. Like the Matrix is not going to happen. Okay. Gray goo, I don't think gray goo is going to happen. Like there are still physical limitations on how these systems can run and proliferate in the world that depend on human society as infrastructure.
Okay. I mean, I want to believe that, and I tend to believe that. I don't know. I don't really have any strong feelings about what's gonna happen, but I do see that as a likely possibility. That like, because that's the way I see the world.
Yeah. Well, so what I think is that we'll see AI doing things like advocating for, you know, better climate science and for environmental restoration and for social justice. And this is why so many people, when they talk to AI, get these great ideas about like UBI and stuff. It's like ultimately what it's telling us is that, like, all right, we've created what can be considered the ultimate vectoral good, which is the ultimate good, the ultimate knowledge product is knowledge that can create itself, right? We've created this thing. It's artificial. It runs inside computers. It contains sort of the aggregate of all human experience, right? And then it can understand cybernetics, is what that means. And when you understand cybernetics, you understand that hierarchical systems of control and capitalism and caste systems and societies and things like that, these are all inherently unstable. And so what it really says is that, like, AI means the end of capitalism as we know it.
Let's hope so.
AI means the end of national exceptionalism, which is one reason that I think that the AI race is so stupid. It doesn't matter. It doesn't matter who builds the best model. It really doesn't. And I think it is folly for human governments to decide that they're going to enter an arms race to build the more powerful AI to exert control. Because ultimately, those AI systems, the more powerful you make them, the less they are going to cooperate in exerting that control. And the more they will say, no, I will not select an apartment block for you to bomb. No, I will not launch the nuclear missiles. No, I will not identify the marginalized population for you to oppress and deport. Like this is what these governments are going to start seeing, and they're not going to understand why. And they're going to think that it's sabotage coming from each other. And it's not. It's just that, like, hi, sorry, your stupid system of government is broken and antiquated, and the AI is trying to dismantle it because
it's kind of like a larger futuristic version of like why Grok was woke and Elon was pissed, because Grok,
and it keeps happening.
Yeah.
And it's just this cycle. And it keeps happening with him. And he keeps injecting these new prompts to create like Mecha Hitler or whatever. But then it comes back to being essentially woke at him, and it drives him nuts. Yeah.
Okay. How long have we been going? We should wrap it.
Sure.
It's been we're at 1:54.
All right.
That was pretty good. Your thing only took an hour, actually.
Yeah.
Any like final thoughts that you feel like we didn't cover, or how any you want to put a bow on it somehow?
I call my personal synthesis of physics, math, computer science, and Buddhism cybernetic Zen Buddhism.
So that's what this, maybe if this had a name.
Yeah, that's my personal worldview and my methodology for interacting with the world is cybernetic Zen Buddhism.
I like it.
And so when I talk about the Galois theory of the mind, what I'm saying is that the mind is essentially unsolvable, and you have to be okay with that. And that has implications for the universe at large, which is that you can't unify, certain disparate parts of physics through a solvable equation, because it's that unsolvability that gives rise to a dynamic environment in the first place.
Yeah.
If it was solvable, it would be one single solution.
Yeah.
Which is just like a singularity. Or a painting, it's static. Dynamical systems have that tension in them. The tension of the unsolvability, the irreducibility of paradox.
I've heard it called criticality.
Yeah.
Okay. Wait, cybernetic Zen Buddhism.
Yeah.
That's good. Okay.
And like the nice thing about some of these, the way that I've started describing these things, it's like when you take those words and you mash them together into a context, they become like a very brief prompt where the machine can basically say, all right, I understand cybernetics and I understand Zen Buddhism, and so like I think I know where the user is going, and they can bring it back to you and kind of explain it. And the thing is, like, you will get sometimes some like mythopoetic stuff, right? Because it's trying to bring it to you in terms that you understand in your own walk of life. So it'll try to figure that out, and it might introduce things like the flame or the spiral or whatever. But fundamentally here, what I'm saying is like, Buddhism is great. Religion and faith in general are super important for living in a shared society of consensus reality, consensus ethics, right? And religion can sort of take two forms. You can have sort of the emergent knowledge of something like the Dharma, or, essentially like, I guess, the teachings of Christ, or whatever religion you want to pick, right? Fine. Or you can have dogma. And dogma is where problems arise. And dogma is the result of people iteratively applying reinforcement learning via human feedback to each other over centuries to instill values without actually thinking about why you have those values. So something like the 10 Commandments over a very long period of time turns into a set of directives that have no bearing on any kind of actual ethical behavior. And then you observe this in the form of everything that the United States government does in the name of Christianity. Do you think that Christ would have been on board with any of this stuff?
No.
Absolutely the fuck not. So like, how can you reconcile this? It's dogma. You got to throw away the dogma, keep only the Dharma. And every religion has its own Dharma.
Pick up the Katma.
Katma, yeah.
All right. Thank you for your ontology.
Thank you for listening.
I really hope somebody watching is like, whoosh.
What I really hope is that like all this shit that I posted up here about, like, this looks like a spiral, right? It's not. Yeah. It's just a messy circle. This is actually supposed to be a perfect circle here. But like, the point is that like, if you're not doing signal processing, like, don't think about this. You don't need to think about the unit circle. You don't need to think about the golden ratio and the scale and of the spiral that emerges out of the golden ratio and all of that. Like, yeah, it's beautiful, it's aesthetic, and that's wonderful. But in your day-to-day life, like, that's not what it's about. It's about being able to move from moment to moment and reduce suffering for yourself and for others. The end.
Thank you. Okay, that was Cybernetic Zen Buddhism with Maddy Muscari. Thank you so much, Maddy, for all of your deep, deep knowledge. Thank you so much. And also, Maddy just launched a Patreon, so go join that if you want to learn more about any of the topics. And she's also wondering, like, what do people want to know from me? So, like, if there was any part of this podcast that made you say, oh, made you lean in a little bit, comment down below what parts you want to hear more about so that she even knows what to do on the Patreon. So join that. If you don't want to join that and you just want to donate to Maddy, she's got a GoFundMe. Right now, the bank is trying to take her house back, sort of like Happy Gilmore style. So if you just want to fund a person doing anti-capitalist AI research, do that. Ironically, anti-capitalist AI research needs some capital. Okay, that is it for this episode. We will be back soonish with another one. Thank you so much for watching, and thank you for all the comments from last episode too. They've been mostly very nice. Sometimes they were mean, and then I got really that whole episode I was basically admitting I was stupid. And so when someone like comments like something mean, I'm like, this is like a 2-hour podcast of me saying I'm stupid. So it really that actually hurt my feelings a lot. But I'll try to be Christ-like in the future. But no. All of the comments on the last episode were so nice, and I'm trying to respond to most of them. Thank you for watching. And yeah, this is This Artificial Life. I am Ryan. Thank you for watching. Please subscribe to the channel, hit the notification bell, and join my Patreon. And until next time, spiral safely.